At the moment, I do not see a question coming in, but silicon carbide is quite a mature technology nowadays. The question to you all is the pricing structure, that's a simple question from my side, is the pricing structure now at a point that people in general can start designing silicon carbide devices into their applications rather than taking the silicon switches like MOS and IGBTs?
Are you asking the question to us all? And the first to start is the first, or do you nominate somebody who should answer?
No, the first who wants can say hello, I answer.
Okay. So, hello.
Michael,
I answer. So it's me, Michael Voelkl from Infineon Technologies. And thank you for the question on the adaptation of silicon carbide in regards to also pricing versus silicon carbide versus the standard silicon products. And what's basically happening is, of course, as more and more opportunities, more and more sockets get transferred into silicon carbide, we get a huge lever on basically standard cost downs, which is the main driver for price downs, of course. Nevertheless, silicon carbide, due to the sheer nature of the technology, will, as we see it, for sure not and never reach a one-to-one replacement to silicon. But what it does, it offers, with all the additional features that silicon carbide can offer you, simply cannot reach in some cases with the standard silicon devices. The overall system benefit for those sockets will become more and more evident over time. And in regards to some specific applications, you can already see them, as maybe you've seen in my part of the presentation, for servo drives applications.
Michael, thank you very much. We have already 3 questions from the visitors. The question first is addressed to STMicro. Does the ACE pack SMT include the isolation already? If so, which one? Graphite, silicon foil, Kapton? Is a question to STMicro.
Thank you, Bodo, and thank you for the question too. Yeah, so as I explained during the presentation, the top side of the specs meet is fully isolated from all the other pins. We offer 2.5 kilowatt isolation. We got this, so to say, UL certification. We have applied already for the 4 kilowatt that we expect to get soon.
Okay, the next question is to all the presentations, the benefits of SiC are quite evident. Why are so few manufacturers are actually using them today? What's currently the biggest hurdle to use SiC? Anybody of you who want to take advantage, the biggest hurdle of using SiC?
Yeah,
Is it
I can.
availability?
I can take. Okay. Sorry, Kevin.
Oh, no problem, Michael. This virtual conference is basically a measured approach to see who jumps on first, so it's okay.
I don't want to, I don't want to jump the gun all the time.
No, it's no problem. I was actually just typing a response to another question, Bodo, but if I heard right, the question is, why is it taking so much time for people to learn how to design properly with silicon carbide? And I think it's because for so long we have been accustomed to the slower switching speeds possible with IGBTs. And once we start increasing the profile, the slope of those edges, this is what manifests a lot of problems that the power community hasn't seen before. So I think this is really going to be an evolutionary process by which the design engineers learn best practices and then also continue to innovate. And I think we're going to see a lot of innovation capabilities coming through improvements in passive components. But I think this entire ecosystem needs to, we're going to see it mature. We're already there. We're already seeing a lot of production design wins in silicon carbide. People are having success, but I think it's no different than if you look back to, as you know very well, Bodo, in the early 1980s, designing with IGBTs probably faced some similar evolution.
Exactly, Kevin. That's what I want to add here. When I went around in Europe in the mid 80s with IGBT designs, the engineers hesitated to go ahead, and it took some while that they made progress, and it was quite a work for me to get them into that loop. And exactly that historical thinking had initiated in my thought to go and have these wide bandgap conference to help designers making progress. Okay, we have another question for ST, On, and Infineon. What portion of the auto SiC market opportunity is to module makers, and what portion is bare die only? Is there a danger of silicon vendors stepping on the toes of the module makers by producing their own modules?
Well, I'm not sure, but I think we had similar question in the session yesterday, if I'm not wrong.
Yeah.
Right.
Yeah.
Oh, it's a complex question. Do you want to start, Michael?
Maybe. I would say this danger exists, yes, but I think luckily for all module manufacturers that we are one as well, it's not that easy to manufacture those modules. There are some automotive manufacturers that use very, very specific modules and also discrete packages, where of course bare die is a way to go and is an idea to go. But to be honest, very sheer silicon vendors stepping on the toes of module manufacturers, if by the means of module manufacturers or module makers is meant to be companies that do only the packaging, I still think that dealing with the packaging and the chip in one hand is giving a lot of advantages in terms of reliability. So
let me
if
make
this
some
answers the
comments
question.
there. I have been involved in the 90s, seeing Semicron, seeing Danfoss Silicon Power, and these are module manufacture where IGBT, MOS, and all purchased from several other vendors, and just by an example of these both companies, they have very successful but value added to end customers, and the market is so huge that I probably do not see that there is a big problem not to serve that market from module manufacturers and semiconductor who are also module manufacturers. Warstein for a long time, now part of fully Infineon, was a module manufacturer that had went through a certain struggle to be fully adapted into Infineon. So I think there shouldn't be a big problem. I think it's more important that the designs get done within the time frame the automotive industry needs them. Okay, let's continue to the next questions. It's again, what portion of the auto SiC are quite evident? Why are so few manufacturers are actually using them today? What's currently the big, that's again the same question.
Actually,
the next
sorry.
The next question to ST, if the top side of the package is isolated already, what is the reason for the thermal interface material? Is this required to compensate the height tolerance?
Yeah, thank you for the question. Yes, so part of the answer is included there. So yes, is to compensate both the coplanarities and tolerances in the solder of different modules inside the same PCB. The other reason is that in some cases, the distance between the pins and the top side, which is 4 millimeter, which is also the distance to the heatsink in the end, might be not enough in some cases. If it is the case, then one isolated thermal interface material could be a solution. With a slight disturbance or increase of thermal resistance as it was shown. So the best results came with a simple thermal grease, and we showed 3 different options, all them isolated in the compromise between the price of thermal interface, material, thermal properties, and so on.
Okay, the next question is it inevitable that Tesla will move off 400 volt to 800 volt and above, given faster charging times? What will that mean for the existing SiC charging infrastructure of Tesla and others? Will retrofitting be necessary? I think that's more an answer from Tesla than I do not know how close that is already on your side.
Bodo, if I can, just really quickly, I agree this question is probably best answered by Tesla. But if I can, I'd like to connect us back to a previous question, which is, what's the reason for slowed adoption, slower than expected adoption of silicon carbide? And I think this is part of it. We expect for silicon carbide to have dramatic uptake and hockey stick growth due to price erosion that comes from what? Automotive adoption. Well, automotive adoption is a bit difficult because as a supply base, we're struggling with the lack of standards in the automotive industry. What power packages are people going to use? What DC link voltage are people going to use? So a lot of these things are a bit turbulent at the moment. And, you know, as a supplier, and hopefully I'll get some head nods from the rest of the people on the screen here, but I think we would love to see some community standards pursued by some of these large segments so that as a supply base, we can better respond and help with the adoption.
Thank you, Kevin. The next question is...
Sorry, maybe just to add on this question as well. This transition going to higher breakdown voltages, I think it's already quite visible in the market, and this is also why the trend goes more and more towards 1200 volt silicon carbide MOSFETs in these charger applications. Just due to the 800 volt DC, we need the 1200 volt silicon carbide MOSFETs in these regards. So this is why we see a huge pull into higher breakdown voltage and 1200 volt silicon carbide MOSFETs as the demand.
Okay, there is the next question to Jan. Coming back to the questions, what currently is the hurdle for the use of SiC? What's your opinion?
Okay, for using SiC, I think the main thing at the end customer side is the higher frequency switching. So basically, engineer probably are used to ultra fast, hyper fast diodes, IGBT. Okay, if you go to very high frequency switching in a very fast switching PFC, for instance, or some half bridge, full bridge application, the higher speed in itself is a challenge for the engineers. But apart from that, it is similar as designing with silicon in principle. So there should not be a big hurdle apart from working with higher speeds, faster slope rates, etc. Maybe Nick, my colleague here, he can comment.
Yeah, you will have to take into account that you're going to need other passive components as well. You need to take care about layout. You need to, so that's things. But I think that a similar question was already answered. It's a matter of getting the engineers used to the properties and the benefits that you can use from the silicon carbide components. And of course, for the short term, it will still be that the silicon carbide components will still be quite a bit more expensive than silicon components, which for some segments in the market may be a significant problem, and that will probably limit the use of these components in these markets. But for the markets that have the challenging markets that can benefit from silicon carbide components, most of it will be the engineering. The engineering challenge that I think Jan and I think Michael as well already mentioned.
Now we still have another question here. In charging infrastructure, SiC seems a good technology to adapt to high power level. Do you see the OEMs are ready as well for battery and other level of design?
It's, yeah, could be a similar answer again. I think in the end, also the OEMs will be able to do this kind of job. But it's a matter of getting the engineers ready to apply this technology.
Yep. Thank you.
Couldn't agree more with Jan and his colleague.
Nick.
Hi.
So we're waiting for more questions. 5 minutes roughly left. So far, we see that there is a lot of areas where still can be made progress, and design engineers can be quite busy to use the devices in a proper manner. And you all there can be helpful by articles and application notes, and the magazine in my background helps to carry the message out to the world. So that's one thing which makes me happy, that this works quite nicely. And if I say world, you see in the background my globe, which I have gotten as a Christmas gift when I was a 6-year-old boy. That's quite a while ago. That's 61 years ago. So it's still made it all the years to now.
I guess if we're running out of questions, our presentations were very good.
Thank you to your There is one question just coming in. Will there be with SiC in near future monolithic ICs with integrated drivers, like the gun ones?
Yeah.
I think from a philosophical standpoint, this is sort of the holy grail for every semiconductor technology, isn't it? When we have an active switch, the closer we can get the controls to the switch for whatever the reason, whether it's simplicity, compactness, reducing parasitics in the gate source loop, whatever the cause may be, I think all technologists are after monolithic integration. And when you say like with GaN, I assume you're talking about the GaN Fast product lineup from Navitas. If that assumption is correct, by the way, I think that solution is quite impressive with some of the performance results I've seen. With that aside, though, I think today where we're seeing activity in silicon carbide monolithic integration or near or close to it is really for high temperature use and integration with high temperature sensors, and where people need high temperature capability, small signal components. We see silicon carbide developments there, but it's really not, these are not commercially ubiquitous products by any stretch. Today, I think it's probably a cost obstacle to render the control semiconductors in silicon carbide because the materials are still quite expensive. But I do think that at some point in the future, we'll all be headed in that direction. Not speaking for others.
Anything is possible. What I remember in standard IGBT processes, the active clamping was a high integrated thing for automotive IGBTs ignition. But the last question here is, how do you see the capacity expansion of SiC in Asia, considering it one of the biggest electro vehicle markets? Would it be a threat in near future?
I assume with whole Asia, we're talking about the focus on Greater China. And I can say that what we see in the market is there is as the market gets more and more attractive, a lot of companies manufacturers, it become a threat. But for the near future, I would rather say no, not yet. It's as we've discussed in basically all the questions that have been raised before. It is not that easy to manufacture silicon carbide and have all processes under control within the whole manufacturing and packaging line. So it will take some time until, let's call it newcomers, newbies, or however you want to call them, will be capable of doing so and manufacture reliable and good, let's call it good enough material.
Gentlemen, we have to come to an end. We have half an hour of fruitful discussions. If there are more questions which may reach my desk, I will forward them by email to you to answer specific questions. Just now, there is no more. So I will say thank you. Enjoy the rest of the day. Enjoy the more upcoming presentations. We'll hope to see you next year at the real event again.
Yes, agreed.
Yeah.
I miss seeing you guys in Munich.
Yeah.
Bye.
Thanks so much.
Thank you.
Very much
Have a
looking
nice
very much
Christmas
looking
time.
forward.
Take care.
Bye.
Thank you very much.
Christmas.
Yeah.